completing the square, what is the point? More or less, the idea is to solve a quadratic equation that's not factorable. We do so by essentially adjusting the left side of the equation so that it becomes something we love. It's called a perfect square trinomial. So let's practice just completing the square for a moment based on your conclusion from the exploration. From the exploration, you folks were able to see that we got the middle value there by squaring b cut in half. So if we look at these examples here, do you see how the middle b value in the problem is 6? If we want to find the number that allows us to complete the square, we have to take 6, cut it in half, and square it. 6 divided by 2 is 3. 3 squared is 9. Now what this does for us is it makes this problem factorable using the square root method. It turns it into a perfect square trinomial. We use the square root method, like I said, to factor perfect square trinomials. Can anybody tell me how this factors? I need somebody to factor x squared plus 6x plus 9. Go ahead, John. Yeah, I like how you said that. X plus 3 quantity squared. That's going to be essential for today's lesson. I know some of you like to write it as x plus 3 times x plus 3, but you got to write it like the big kids if you hope to use the square root method. You'll see why it's important to write it this way in just a few minutes. Okay, we're going to do it one more time for fun. On the left side, I want to complete the square. What that means is we have to turn that left side into a perfect square trinomial that is hence factorable. To get this number that goes in the blank, I take this middle term, this b value here, cut it in half, and then square it. Negative 4 divided by 2 is negative 2. Square it up, you get 4. This is now factorable via that square root method that we talked about when we did the factoring part of this chapter. Can anybody tell me how x squared minus 4x plus 4 would cook down to be the product of two binomials? How's that factor? What do you think, Tammy? Yeah, very good. I didn't mean to scare you. Sorry. But you did a nice job thinking on your feet. Good job. Oh, wait. Is it plus? Rats. I totally bought what she was selling. John. No. Minus. Yeah, just the minus. I was so excited that she got the factors. There we go. If you took x minus 2 times x minus 2, that gets you the negative 4x when you put your outers and inners together. John, if you did a plus and a minus, you're not going to get your middle term at all. It falls away. Do you remember that? Yeah, that's called a difference of two perfect squares. That's not a perfect square trinomial. Okay. All right, so in general, moral of the story, our formula for today is going to be b divided by 2 squared. This is the formula that helps you find that constant that you have to add on to the left side in order to complete the square, in order to make a perfect square trinomial. Okay, now there's a nice little chunk of steps for you to go ahead and copy. Steps 1 through 5 are all yours. You're going to need them. Tonight's assignment, I believe you have 4 problems to do. This is not an assignment where you could just put your notes away and not even look at them. I don't know any students at this level who can just go home and do these 4 problems without looking at something else first. Because there's 5 steps. You're not going to retain the 5 steps after I show you 1 or 2 in class. You're going to need to look back at what we did today to help you move through a couple of problems on your own. Now, like I said, this is a 3-day lesson. So as we move through, you're going to need less and less support. Ideally, by the time we get to Friday, you could do these without looking at the steps. But these are the 5 steps we're going to do. Step 1. We solve for the constant term. That's super weird. In plain old English, you move your constant to be by itself on one side of the equal sign. Step 2. We don't do that until tomorrow. It's not necessary in the problems you see today in class or tonight on your homework. Step 2, you're going to divide through by whatever is multiplied on the squared term. You don't even have to worry about that for tonight. It's not going to happen. Step 3, you're going to calculate b divided by 2 squared and add that onto both sides of your equation. What's nice about that is then it makes the left side factorable. So in step 4, you're going to factor the left side and simplify the right side. And then in the last step, you solve using the square root method, aka SADMEP. Questions about that? All right, giddy up, let's do it. This is all weird looking. You all right? Everybody okay? Oh. Is this you, Eddie? You good? Okay. Thanks, Ben. Good looking out. Way to be a friend. Okay, so I need to borrow this for a second, make it bigger. Okay, in the first example here, what I want to go ahead and do with you is just solve by completing the square. Like I said, it's the worst method. You never saw this in Algebra 2. Doesn't matter what Algebra 2 class you came from, you've never done this before. So here's your first go at completing the square. First of all, you got to decide, well, when am I going to use it? If I look at that problem, it is not factorable. There are no factors of -6 that could possibly give me 2 in between, so I'm kind of stuck. I have to go to another method. So step 1 in completing the square is to move the constant to the other side. To do so, we're going to add 6 to both sides. So we get x squared plus 2x equals 6. And you'll see there's a big hole in my problem. That's because a number goes there. The formula we have for today's lesson to get that number comes from my b value, if you recall. This is where your exploration came into play. You're going to take your b, divide it by 2, and square it. So I had to take 2 over 2 and then square it. 2 divided by 2 is 1. 1 squared gives me 1. Please understand, by the golden rule of algebra, what you do to one side of an equation, you must always do to the other. So do you see how I added 1 on the left? Anybody care to guess what number goes on the right there in that red box? I see it in fingers, nice fingers, good. Yeah, you add 1. Good. The idea here is that that left side is factorable. Eddie, you will not ever sit there again. If you take a look, the idea is to make this left side now factorable. We have x squared plus 2x plus 1. So I have to factor that. How do you factor x squared plus 2x plus 1? It is a perfect square trinomial. John. Yeah, x plus 1 squared. Good job. So the left side factors, it is x plus 1 squared. Notice we didn't write it as x plus 1 times x plus 1. You're going to see why, for those of you that were icking that a little bit earlier. This is now the square root method. And you couldn't square root when it was x plus 1, but now that this is squared, I can get rid of that. So I'm in my last step. Square root both sides. So I have x plus 1 now equals plus or minus the square root of 7. Because I get 2 answers when I square root that right side. Subtract 1 from both sides. And those are your 2 answers. You have -1 plus the square root of 7, -1 minus the square root of 7. So those are our 5 steps in a nutshell. John? Not yet. the quadratic formula comes from this method. Yeah. Now, could you use the quadratic formula to solve a quadratic? Yes. But on the test, here's how this rolls out. I say, hey, solve this with completing the square. Solve this with a quadratic formula. Solve this with factoring. So that's to test all of your methods. If you can't do this method, look at how many steps there are. It's no good. Yeah, true. We're going to do part B. Make a little slide for it. That'll be our last problem of the day. Step 1. You want to solve for that constant term. Oh, that's already done for you. Sweet. So do you see that -6 on the right side? The constant is solved for. That's taken care of. I usually rewrite this, though, to give myself a little bit of space. Because I'm supposed to complete the square on the left-hand side. Ooh, to be continued. Make sure you look at our 5 steps in our sample problem when you do. You have 4 of these, I believe, for tonight on your own. And we will finish this up over the next couple of days.